What are similar shapes? Well, two shapes are similar if they have the same shape but not necessarily the same size. So their corresponding angles are the same. However, their lengths are linked by a scale factor. Now, what does all this mean? Well, before we actually get into the maths behind it, I'm just going to show you some examples of what similar shapes look like. So here we have two squares. Now, notice these squares are similar because let's say this square had a length of 4 and this one had a length of 8. Well, since they're squares, all their sides would be the same length. So notice there is a scale factor between these two squares, as there's a scale factor of 2 because 8 divided by 4 is 2. So let me just rub all this out. To go from this square to this square, you just multiply all the sides by 2. So since there is a scale factor between their lengths, these two shapes are similar. And obviously their angles are the same because it's a square. All the angles are right angles. So their corresponding angles will obviously be the same. Now, let's draw some attention to this point, their corresponding angles. So let's look at another example. Here we have two triangles. Now, triangles do not always have the same angles. So for them to be similar, they have to have a scale factor between their lengths. Let's say this is 10, this is 5, and this is the important bit, and their angles have to be the same, their corresponding angles. So if this is 45 degrees, this one will also have to be 45 degrees if they are similar. So sometimes we may not be told that two triangles are similar. We may just be given the angles. So let's say this is an angle of 30 and these have angles of 60. Now I know this is not drawn to scale, but I'm just trying to make a point here. And then we are told this has a length of 10, this has a length of 5, this has a length of 3, and we are told to find this length, x. Now, in the question, we don't get told these two triangles are similar. However, we can clearly see they are similar because let's look at each corresponding angle. So this angle corresponds to this one. They are equal. Check. We do this for the other two angles. This and this are the same. And these two right angles are obviously the same. So since all their corresponding angles are the same, these are similar shapes. So we know their lengths all have a scale factor. So looking at this side of the first triangle and this side of the first triangle, we see we have 5 here and 10 here. So the scale factor is multiplying by 2 because to go from 5 to 10, you need to do 5 times 2. So similarly, to go from 3 to our second triangle, we need to multiply the length by 2. So the value of x will just be 3 times 2, which is 6. Now I want to move on to the bit where we actually bring in the maths to this. So let's say we have two squares. At the moment they're squares. These squares have lengths of 2 and 4. Now just notice any two squares are similar to each other because they all have the same length. So there's always a scale factor between all the sides. Now, so for these squares, we have a length scale factor of 2. This is important. So length scale factor, I'll write length for this, will have area and also volume. I'll explain this as we move on. So the lengths have a scale factor of 2. Let me write it like this, scale factor. So their scale factor is 2. So the scale factor is 2 of the lengths, but let's work out the area of these squares. So this first square, let's call this one square A, this one square B. So the first square has area 4 because we do 2 times 2. So it's 4 units squared, whatever the unit is. But for the second one, the area is 16. Why? Because we do 4 times 4. So what is the area scale factor between these? Well, we do 16 divided by 4, which is just 4. So let's write that here. The area scale factor is 4. Now, if we turn these squares into cubes, so wait 1 second. Let's just imagine these have now been turned into cubes. So now we have 2 cubes, and these cubes, the first one has every side length 2. The second one has every side length 4. This is because they are cubes, so all the sides are the same. How do we find the volume of the first one? Well, we find the front area, which is 2 times 2, which is 4. Then we multiply by the depth of this cube, because by multiplying by the depth, we are sweeping out the whole volume, if that makes sense. So we do 2 times 2 times 2, which is 8. So the volume of cube A equals 8. Similarly, for the cube B, we do 4 times 4 to find this front area, which we worked out as 16. Then multiply by the depth of the cube, which is 4. So we do 16 times 4, which is 64. So what is the volume scale factor? It's 64 divided by 8, which is 8. So let's look at the scale factors now. We can rewrite 4 and 8 as 2 squared and 2 cubed. Now this is the important point that I want to make. This is the whole point of this topic. When we have a scale factor of lengths, let's say the scale factor is x, we also have a scale factor of area. Now this scale factor of area will not be x, because it's not 2, it's 2 squared. So it's the length scale factor squared. And similarly for the volume, it's the length scale factor cubed. So we can see from here, to go from the volume of the first cube to the second cube, we don't multiply by 2, which is the scale factor of the length. We multiply by the scale factor of the length cubed. So to go from volume A to volume B, we multiply by 2 cubed. So between any similar shapes, if we want to go from the first volume to the second volume, we multiply by its length scale factor raised to the power of 3. So this point is a very key point. You must remember this. This is the whole point of the topic. Without this, there's no point of me even explaining this video. There's no point of you watching this video. So let's do some examples to get this solidified into your brains. Okay, let's do an example question to sort of practice this new skill we've learned. In this question, we are told we have 2 similar cuboids, A and B, and we are told the volumes of both cuboids and nothing else. We are asked to then find the length of this x value. We are told its corresponding length of the other similar shape, which is 32. So to go from 32 to x, what we need to find is the length scale factor, because x was multiplied by some scale factor, let's call it h, to give us 32. So x times h equals 32, and h is our length scale factor. So to find the value of x, all we need to do is x is 32 divided by that length scale factor. Now, how do we find the length scale factor? Well, what we look at is the information we have in the question. We are told the 2 volumes of the shapes. So we can find the volume scale factor, which is going to be 4096 divided by 8. And that is just 512, I believe. I'm using a calculator for this. You can do it by hand, but just for speed, I'll do it with a calculator. So we are told the volume scale factor is 512. Now, if we look at this mess again quickly, remember I said the volume scale factor is equal to the length scale factor raised to the power of 3. So let's go back to our question. Let me scroll to the side. We have found the volume scale factor, but we want to know the length scale factor, which is h. The volume scale factor is the length scale factor raised to the power of 3, and that is equal to 512, as we found. So to find h, we just cube root both sides. So the cube root of 512 is just 8. So now we have found the length scale factor that takes you from cuboid A to cuboid B. So now we can just simply find x. X is going to be 32 over h, because we just found that out here. So 32 divided by 8. So our missing length x is equal to 4, and that's our final answer. Okay, so here's the final question. Okay, so here's the final question that I'll go through. Now, this question is quite a bit harder than the other one. It's a past exam question. It was question 19 and it was worth 3 marks. However, since it was near the later end of the paper, it was considered one of the more difficult ones of the paper. So let's just go through this. We have 3 spheres, A, B, and C. Now, this is an important point I want to make. Some shapes are always similar to each other. No, the question doesn't need to tell you. So this question is telling you we have 3 spheres, but they are automatically similar. We don't need to be told that, because notice, a sphere is just a 3D circle, and any circles are similar because there is always a scale factor between the circles. So 2 shapes you need to remember that will always be similar are squares, which are the same as cubes, and circles, which are the same as spheres. So if you ever get a question about cubes or spheres, know automatically they are similar. The question doesn't need to tell you. Anyway, looking at this question, we have 3 spheres, and like I said, they are automatically similar. So we need to just bear that in mind while doing this question. We are told the volumes of sphere A and B. And we are also told the radius, the ratio of the radius between sphere B and C, which is 1 to 2. We are asked to find the ratio of surface area of sphere A to sphere C. Now, in this question, radius acts the same as length. So for the scale factors, radius and length mean the same thing, and the surface area is the same as area. Look, we're going to work in ratios for this question because we know our final answer is going to have to be a ratio. What we do is, let's write the volume. So we have the volume of A to B. Now that is 125 to 27. Now to go from volume to the lengths, remember, since these shapes are similar, there's going to be a scale factor. So the lengths of A to B is going to be the volume scale factor, but we take the cube root of it. So we take the cube root of 125 here, so that's going to be 5, and the cube root of 27, which is 3. So the length scale factor, the lengths ratio, are 5 to 3. Now, we are told the ratio of the lengths of sphere B to C. So let's write it here. B to C is 1 to 2. Now, we eventually want to compare A and C. So let's first compare them lengths-wise. So combine these 2 ratios. Now, there are a few ways to do this, but what I'm going to do is the linking factor between these 2 ratios is B. So if we have the B values in the ratios the same, then we can just straight up add the C and A. So what I mean by this is we have a ratio, the B's ratio here is 3. So let's just make it 3 over here as well. So what we can do is multiply both these by 3. So we get 3 to 6. Now we can straight up combine these 3 ratios. So we have the lengths of A to B to C is 5 to 3 to 6, as we're just reading off here. Now we are told the ratio of the surface areas, not the lengths, of sphere A and sphere C. So let's write the lengths of A to C here. A to C is 5 to 6. Now to get the surface area, since there are similar shapes, this is the same as the area. So we square these values. So A to C is going to be 5 squared, which is 25, and then 6 squared, 36. So the ratio of the surface area of A to C is just 25 to 36, and that's our final answer. Now, this question was much harder than the other ones. However, if you can understand these, then you have basically understood this whole topic as far as GCSE questions go. So I hope you enjoyed this video. Make sure to like and subscribe. I'll see you in the next one.